here is another example for class 5 dealing with planetary gears in ME470. I believe I have some type of interesting little thing here to kind of help you figure out what this configuration actually looks like. Because this is the figure that's shown in Shigley. And what's important here is, for one thing, to figure out that when they show this little gray thing, they mean that this right here is fixed. Right? So this is a stationary gear. You could see these dashed lines that the shaft is passing through here. You can also see that this is a shaft that's connected to 4 and 6, and it's passing through the carrier. And also the carrier has this nub, and gear 3 rotates freely about that. So the tooth numbers for these are number 2 has 20 teeth, number 3 has 16 teeth, number 4 has 30 teeth, number 6 has 36 teeth, number 7 has 47 teeth. That's an interesting one. And it also mentions that gear 7 is fixed by way of showing that little gray out area. And I said, if shaft A is turned through 10 revolutions, how many turns will shaft B make? And you'll notice that these are aligned. A good exercise is to make sure that we're counting the number of teeth here, so that we might look, and we go that 10, that right here, because there's 20 teeth. Let's say 10 is the radius, plus 16 plus for this would be 1/2 of those, right? So that should be 30, right? So 15. So what did I just say? 10. What I'm a little concerned about is this guy with here, the 47, because it's going to be 1/2 a tooth. How is that going to work? I got to wonder if this worked out. Well, what would have to happen is these aren't the same pitch as these. That's what would have to happen for this to work out. The funny thing is that I did make this at one point. I don't know. The SolidWorks model that I made for the thing is gone at this point. But I had 10 and 16 and 15, right, is 41 teeth. And then I would have 1/2 of this, which is going to be 18, but then 1/2 of 47. I don't like that. Like, what I would say is that if I subtracted out 18 from 41, I'd have 23. So this should really be 46 teeth right there. That 47, I don't buy that. I don't know where that came from, and I think that's incorrect. In fact, let me double check here, because I'm making a video. Just put that anywhere. Because I'm making a video, I can do anything I want, right? It's not like class has to be a certain length to the thing. So let's check it out. Let's see what happens here. So that's chapter 13, and where is this problem in chapter 13? Right in there. Oh, check it out. There's 46 teeth. I wonder where that 47 came from. That was really weird. I'm gonna go. You know what? I'm gonna check. I'm gonna go look. Is it my mistake? I must have written it down wrong. Must have done something weird. It's very strange. My bad. So that should be 46 teeth, and I should fix that here. 46. I even looked back at the 9th edition, so I don't know where that one came from, but let's just pretend it never happened. Well, I'm going to continue with, I guess, with my numbering here. Okay, so now I need to find the gear train value E. Right, so I'm going to start with 2 and work my way through. All right, so N2 drives N3, right, and N3 drives N4, but N4 doesn't drive anything. N6 drives N7. Okay, now we have to decide whether this is positive or negative. So let's hold the arm in place right here and turn 2, right, N2, right? right? So what we want to do is we hold the arm stationary and check the directions from the first to last. So let's say that this one is, and did they say how many? They didn't say which way we're going. So let's just assume clockwise, right? So that's going to be that direction. That means that's going to go this direction here, right? So this goes counterclockwise, and then this one goes clockwise. Well, then that, of course, that one goes clockwise right here. So this one goes counterclockwise, right? So we have clockwise in, counterclockwise out. This has to be negative. That's the method. Now, notice that there is 3 stages, negative, negative, negative. That's because we don't have any internal gears, internal teeth onto the thing. So that's another way that we could put it in there, but it's better, I think, to be safe than sorry. So we have 20 to 16. And then from N3, we have 16 to N4, which is 30. But you notice that they cancel out from each other. And then N6, we have for 36, and then we have for 46. So I'm going to get you the right number this time. Let's hopefully. I wonder if there's maybe in the solution manual that they're doing that to be tricky. Seems to me that's kind of evil. So we have a negative 0. I actually recorded this correctly here. Let's see. Did I just? Yeah, I have it. My numbers are correct. 5217. Interesting. My numbers are correct. So 20. Maybe I just read it as, I don't know. Yeah, that gives me that's the number that I previously had. Interesting. So we want to try to figure out. So the arm is going to be. We remember that the arm is going to be. Is that true? No. I'm sorry. In this configuration, remember, 7 is fixed, and that's the last. That's a NL is equal to 0 for us. So in our equation, where we write down E is equal to NL minus NA divided by NF first. NA. I always think that could be final. Kind of like messed up right here. So first and last of the thing. We know that this is going to be 0 minus the arm, NA, right? And NA, by the way, you notice that NA is going to be 5 is going to be the same thing as the shaft, right? So we had input and output, at least for this thing right here. The input is the sun, the output is the carrier, right? The arm, and we're going to call it in terms of the input. Let's just call it 10, right? They said 10 turns, 10 RPM. We'll say it's for 1 minute, right? So whatever, same thing. And then the arm right here, and that equals negative 0.5217, right? So I can work out this right here, and I'll say negative NA is going to be equal to negative 0.5217 times 10 minus NA. We find that NA is going to be equal to 3.428 and turns. And by the way, it came out positive. Therefore, it's going to be in the same direction, right? So this one's going to go clockwise right here. And by the way, this arrow right there was meant for this gear, not for that shaft. But anyway, this guy goes whatever direction he was going, this one's going to go in the same direction, but it's going to go less turns, right? So 10 to this right here. So it's close to being like a 3-to-1 ratio right there for this. And that's enough for this video.